Assalamualaikum warahmatullahi wabarakatuh. I am Mohammad Farid Jani, and I am going to present on analysis of shoreline changes in West Coast Peninsular Malaysia. So this is the contents of my slides. It has introduction, objectives, study area and methodology, result and discussion, conclusion, and also references. So a little bit on the introduction. So what is coastal? Coastal is a zone or border between the land and also the ocean. So coastal is an important zone for human, plant, and other living things that affect the socio-economic activities of domestic and international trades. So coastal erosion is a natural process and cause shoreline to change, which include factors like wave and also tides. There are also many types of coastal, and in Malaysia we know that there are two types of coastal, such as muddy coastal and also sandy coastal. So the development has escalated from time to time. So the rate of erosion and impact on the coastal ecology, such as mangrove and coral reef, has worsened from year to year. So west coast of Peninsular Malaysia, mainly known as Straits of Malacca, is among the busiest roads in the world and prone to be affected by the erosion. So this is the objective of this study. So the first one is to study the erosion rate between Sungai Balang and Teluk Bakung coastal area. Second one is to identify the possibilities of activities that increase accretion or erosion of the shoreline. And the last one will be the implementation of using remote sensing and GIS technology to calculate erosion rate and shoreline movement in the study area. So this is our study area. As you can see, the study area is coastal area between Sungai Balang and Teluk Bakung, Johor. So this area is mainly consists of mangrove area. So the coordinates as follow, and this area is about 22 km in length. So there are several tools and methods that has been used in this study. So the first one is using the remote sensing imagery that has been acquired from USGS website. So the Landsat imagery is acquired, which consists of two sets. The first set is 2016 and the second set is 2021. And the second tool I use is DSAS, or Digital Shoreline Analysis System. So additional to the ArcGIS 10.0, I'm using DSAS as a secondary tool to calculate the shoreline and also erosion. So the last method is photo interpretation. So result and classification of the data is determined and also verified only using the photo interpretation method, because there is no ground data or field data in this study. So moving on to the result and discussion of this study. On your left, you can see the Landsat 8 2016 imagery, and on your right, you can see the Landsat 8 2021 imagery. So this is the shoreline and baseline that has been drawn using the DSAS tool. On your left without the Transat data, and on your right with the Transat data. The red line indicate the baseline, the blue line indicate the shoreline for 2016, the purple line indicate the shoreline for 2021. So this image is a shoreline and baseline Transat with overlay on Landsat imagery. So this graph tells us about the endpoint rate and net shoreline movement between 2016 to 2021. So what is endpoint rate? So endpoint rate is the distance of shoreline travel within the time lapse. In this case is about 5 years, and net shoreline movement is the movement of shoreline referring to the baseline. So endpoint rate determines whether the area undergone accretion or erosion. So the negative value indicate erosion and positive value indicate accretion. So the highest point rate is 13.5 meter per year from 2016 to 2021, which is also the highest accretion. and the lowest endpoint rate is negative 39.17 meter per year of the same duration, which is also the highest erosion. So the highest net shoreline movement is negative 206.55 meter, and the lowest is 69.75 meter. So we're moving back to the graph just now. As you can see, near the left area is the Sungai Balang area, and right near to the right area is Teluk Bakong area. As you can see, erosion occur more on Teluk Bakong area, and accretion occur more on the Sungai Balang area. Okay, we are going to discuss on why does erosion occur more on Teluk Bakong. So this case may be contributed by the housing area and building nearby, and also it is also driven by economic activities such as tourism area and fishing port. So in this study, we also gather data on accretion, which mostly occur at Sungai Balang. So Sungai Balang area, which still covered mostly by mangrove in coastal area, and also another factor might be it carries heavy amount of sediment to the coastal nearby. So as a conclusion, remote sensing and GIS help us to determine the coastal erosion along the shoreline. All the data might be inaccurate because were conducted by an inexperienced person. The reason why accretion and erosion occur in an area were done by photo interpretation method. So it is prone to human error. So further study need to be conducted with integration of the ground data or field data to verify whether the remote sensing and GIS data is true. I think this is all from me. Thank you for watching.